class. Welcome to PUAD 628, where we're going to learn about statistics. I know statistics sounds like it's a very scary class, as I'm always told, but just hold tight, hang tight. We will get through this together. I've taught this class enough times now to have kind of ironed out the kinks and wrinkles. I teach statistics in such a way that it's relevant to you and you're not just crunching numbers and not knowing what those numbers mean. So by the end of this course, you should be able to look at the numbers that we calculate and understand what they mean. And you can do that not just in this class, obviously, but when you take on that managerial role at your place of work. We are going to go ahead and get started with lecture 1, where we describe a data set. So I encourage you all to look at this video, watch this video. It kind of tells you about the importance of statistics and sort of what I touched on in the opening slide. But it's a good first step before we even move forward to watch this video. So who uses statistics? Essentially everyone. Everyone uses statistics. Being that this is a Master's in Public Administration class, we focus a lot on public issues, public problems, public policies, and how government agencies use statistical data to understand a number of things, from economic trends, social welfare, environmental issues, and other things. So having an understanding of statistics, even the basic data analysis we learn in this course, could really pay off. It's a lucrative field to know how to use stats and to know how to interpret it and run the analysis. All right, so the first thing we're going to do is learn how to describe data via frequency tables or frequency distributions. So the first thing, the two things that this frequency distributions help us to do is, one, simplify data, and two, demonstrate patterns easily. So here's a table, a frequency distribution, if you will, of the rate of divorce to marriage. And we're looking at the years 1950 through to 2004 here in the United States of America. And so you can see here that a whole lot of data was brought together and was simplified through this one graph. So we don't see all those numbers, but we see a very simplified form of the data in this graph. It also helps us to demonstrate the pattern that's happening. So we can see very clearly that divorce rates were much lower before, let's see here, 1972. 1970, it just kind of started to rise, and then it plateaued between 1978 and now, and who knows what it's doing now in 2016 as I give this lecture. So definitions are really important here. As we move forward, we're going to have 9 lectures, and so as the first lecture of 9, it's important for us to know these terms. We'll start off with the case or observation. It's the object described by a data set. So a person, a group, an object, an event, anything that data set is describing, that is the observation, or that is the case. So if we have a data set of 500 schools, the case or the observation is that school and all of the information that we got on that school. All right, so, and then all of that information, what we call that are variables. So for a school or for a person, if we wanted to want to know what is the person's age or race, gender, language, these are all questions that describe that case, that observation. And that is what we call the variable. The variable is the question. Okay, and we can ask lots of different questions, right, in order to come up with our entire case or our entire survey or questionnaire. And then when we take it further down and we get to even finer details, from the question we get answers, and that's what value means. So the value is essentially your response to the question. Your answer to the question it's the response, it's the value of the variable. So if the variable is age, and somebody said, okay, well, my age is 47, then that's their value. That's the value of that variable age. If the variable is race and someone responded Hispanic or black or white or what have you, that is the value. Okay? And again, the female, that's the value for the variable gender. Okay? More definitions. So, we've got different types of variables, but the way that we understand what the variable type is by looking at its value. Okay, so for an interval or a numeric variable, the values for that variable have to be numbers, exact numbers, not ranges of numbers, but exact numbers. Okay, so a variable, for example, if I asked you what you make on any given day, right? If you said $500, $1,000, $20, that is an interval level variable, right? And so other examples you can see here are, if we're looking for how much something weighs or how long or tall something is, we can see here in inches and pounds, dollars, and all of that. Then we go to ordinal or ordinal level variables. It's one of the two types of categorical variables. So the two types of categorical variables are nominal and ordinal. An ordinal variable has order. So don't ever let that trip you up. Just think about the actual name of that variable type. If it has order, then we say ordinal. If it doesn't have order, then it's nominal. And let me give you some examples here. So and these categorical variables are different from interval level variables because they aren't exact. They can't be exact, otherwise we would call them interval level variables. So if the variable here we're looking for is, let's see, the political ideology, and someone's liberal, someone's moderate, someone's conservative. So there is order there. Moderate isn't going to be first ever between the three of those, right? Conservative can be first, moderate second, liberal third, or liberal can be first, moderate second, conservative third, right? So it can be in any of those two orders, but moderate could never be first or last. So there is absolutely an order to it. So here's another example. And so with that example, we don't see numbers, right? So because we don't see numbers, we know that these are categories. We know that there's a category for liberals, moderates, and conservatives. So one, we know it's a categorical variable, but which type of categorical variable? Well, it has to be ordinal because we see order there. So let's move on to Likert scale. We call it Likert scale, but essentially you've taken surveys before where they ask you, on this scale, do you between strongly disagree to strongly agree, what choice do you select? Something like that, right? And so for Likert scales, it's not an exact number, right? So it has its categories, right? But these categories have order. Yet again, they have order. So neutral would never be first, right? Disagree would definitely be before strongly disagree, because strongly disagree is more, right? It's more extreme, right? Just like strongly agree is more extreme than the regular just agree. And here's a third example with age, right? So we have a variable called age, and we cannot just say, oh, it's an interval level variable because age has a number to it. We can't do that. Don't do it. Don't do it. Don't do it. Why? Because age, in this sense, has is broken down into categories. Okay, so like I was saying, age is not in exact numbers. We can see that age has categories 0 to 10. So the survey may have asked, "What is your age?" Select from the categories below. And so that particular variable would be, yes, categorical and ordinal because there is order to it. Age definitely has order. We know that 38 is much higher than 28 than 18, right? So there is definitely order to that variable, but it's not interval because we don't know if that person is 38 or 35 if they selected a category that says 35 to 40. If they selected a category that says 0 to 10, we don't know if they're 0, if they're 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. We don't know. And so we can only say that this is a categorical variable and specifically an ordinal variable. Okay? And so now let's look at the nominal variable. Again, there's categories, but there's no natural order. So I give some examples here, such as race. We don't know whether white is greater than black. Some people might think otherwise, or even in terms of color in general, right? We don't know if blue is greater than green, is greater than orange, and so on. We don't know if Muslim is greater than Buddhist, is greater than atheist. We can't decipher that. We can't determine that. We don't know if men are greater, whatever that might mean, right? If men are greater than women or if women are greater than men, we don't know. So we can only say that these are variables that have categories, categorical values, and these values have no order. And let me give you another example because my students do this very often, and I feel like I should probably make note of this. Another a nominal variable that is often confused as an ordinal variable is political party. Right? So we talked about political ideology before, where we can say something is liberal and that, it can go to moderate to conservative. But when we have political party, we have to remember that there isn't one it's not increasing and increasing to become something else, right? It's more like the race category and the religion and the gender category. So Democrats versus libertarians versus the Green Party versus Republicans, right? There are a number, and the number of political parties is growing. So we honestly can't say that is an ordinal level variable because where does one start and the other, and stop, and where does the other one start and stop, right? So whereas political ideology has a scale from liberal to conservative or conservative to liberal, political party typically can't. It naturally can't have order because it's like religion and race and gender. All right, let me stop beating a dead horse. And finally, a dichotomous or dummy variable. You can use the word dichotomous variable, or you can say dummy variable. But essentially, that type of variable only has two values. Okay? So if the variable is gender, what is your gender? Well, maybe it might be different in this day and age where people can be, not male or female, but typically there's only two categories to choose from, right? And the two categories are males and females. So that variable, gender, would historically, traditionally, only have two values. The variable that may ask something about yes or no, say, did you vote last year? There's no maybe about it, right? It's yes or no. Those are two values only. Did you get promoted last year? Yes or no. There's no in between about it, right? And so that variable is a dummy variable. What's important to note here about dummy variables is that they are dummy variables, but they must also fit in one of the three types of variables listed here. Dummy variables, they can be interval, they can be ordinal, or they can be nominal, right? This variable, type 4 variable, is the only one that if you select something and say it's a dummy variable, you have to also understand which other type of variable it is. So that so the male, female, right, that would be a nominal variable because we've already talked about it before. We said that there's no order about it. So not only is it a dummy variable or a dichotomous variable, but it's also a nominal variable. There's no order about it. So that yes, no question, whatever that question might have been, we would probably say that that's an ordinal level variable because we know that no is probably higher than yes, right? No means nil, none, zero, zilch, right? Or didn't happen, whereas yes means it did happen. And so you would naturally find order in that, you know? Promoted, not promoted. So you can see some order there. Promoted would probably be higher than not promoted. So that would probably also be an ordinal level variable. Very rarely do we see a variable that's a dummy variable, but also interval. But hey, it's a completely possible, right? We could have had a survey of only people who are 30 and 40. Only, right? So the survey participants, like 10,000 survey participants, and we only interviewed people that were 30 and 40. So for the age variable, we know that it's not a categorical variable because it's 30 and 40. It's exact numbers, right? It's exact numbers, and it's only two values. It's only 30-year-olds and 40-year-olds, right? So that is how we determine what type of variable it is. So it can be interval or ordinal or nominal, but it could also be dichotomous in one of those three. Okay? It could never be the first three, all of them. It could never be that. All right, let's practice. So a researcher wants to understand people's attitudes toward premarital sex. She creates a survey and asks this question to 500 people of various ages, races, educational attainment, and religious beliefs. How many possible observations are in this data set? How many possible observations? If we remember what observation means, it means a person or a group or an event, anything like that, right? So in this case, we asked the question to 500 people. So the number of possible observations is 500. We can expect possibly, if everyone participated and answered questions, 500 observations are possible in this data set. What are the variables, or what are the questions asked? Because remember, variable means questions asked. So what questions were asked in the survey, essentially? Well, they asked about the attitudes towards premarital sex. That's one. They asked the person what their age was, their race was, their educational attainment, their religious belief. So those are the 5 variables. So there are 5 variables, it seems like, right? Never forget the first one. It said premarital sex. People sometimes forget that line and forget really the purpose of the whole study, and they move on to the latter part and go, oh, it's only age and race, education, and religious beliefs. Yeah, so it's 5. What are the possible values in this data set? So if we remember what the questions are, then we can just come up with some possible answers, right? So if the questions are age, depending on whether we think it's a categorical variable or an interval level variable, if it's an ordinal variable for age, then someone who might be 33 may say may have checked the box for 30 to 35 or 34, right? If it's an interval level variable, they may have just written down on the survey 33. What are some other possible variables? Well, someone may say premarital sex is wrong, right? Someone may say I am Christian. Someone may say I am black. Someone may say I hold a PhD. Okay, those are values. So one possible observation in this data set. What is one possible observation? Okay, so don't let this cause you to stumble, because let's go back to that first question. How many possible observations? Well, we said there are 500. So if we say what is one possible observation, we're only looking at one person. Just think about, okay, remove all the others, one person, what is one possible observation? So one person may have said, you know what, premarital sex is awesome. I'm 33. I'm Hispanic. I only have a high school diploma, and I am agnostic. So all of those 5 answers put together make that one observation. Now there are 499 possible other observations, but that's just one of the possible observations that that can come about from the 5 variables that we have in this survey. Yay, we got through it. Okay, and then what is the sample size? Not to trip you up, but this is the exact same question as question number 1. What is the sample size? What are the number of observations? Same question, okay? So the sample size is 500. If all 500 people responded, yeah, that's the sample size, okay? All right, so now that we have definitions down, packed down, we can look at a frequency table. We can see here a lot of things. So from this frequency table, we can see where it says frequency table, and to the right of it, it says premarital sex or sex before marriage. Right, that's what this table is telling us about. It's telling us how people responded to the question, what do you think about premarital sex? So these are the responses. 1, it was coded as 1 for always wrong. 2 is almost always wrong. 3, sometimes wrong. 4, not wrong at all. Okay, and then some people didn't know how to respond, so they selected don't know. Some people didn't know, didn't even answer it. Or it seems like one person didn't even answer it. So beside all, and then we have a system error. When you see that system there, it means there was an error, something happened. So that person may or may not have responded, but something happened in transferring their data, their answers to the software. So we have a system error there. And we can see if we look to the right of that system error, we can see the frequency is 340. 340 out of the 1,000 people that responded to the survey, 340 of those responses are lost, just missing, system error. Okay? So let's take it line by line. Where it says always wrong, we see that 156 people responded to that question about premarital sex. They responded, oh, it's always wrong. Okay? And keep in mind here that this column is talking about absolute frequency. Absolute frequency, this deals with a specific, it deals with the number. the number of observations for a particular value. The number of observations. So 156 people said it's always wrong. How many people said it's not wrong at all? 280 people said it's not wrong at all. Okay, do we see that? All right, then we move over to the next column, and we can see percentages. Actually, before we move over, let's look at the total columns. Right under not wrong at all, we see total, and that's the total for the people who actually provided valid responses. You can see up to the left of the responses, it says valid. Those are the valid responses. So of the total of valid responses, 636 people actually, of the total of the total number of people that were surveyed, 1,000 people were surveyed, but only 636 people provided valid responses. The responses we see numbered 1, 2, 3, or 4. Okay? And we can see at the total for missing not valid responses, because we have people that said, I don't know, people that skipped the question and didn't answer, and then people whose responses somehow got missing in the system and had an error. So of the missing responses, the total is 364 missing responses. And of course, if you take 1,000, which is the total number of people we set out to survey, we see that 636 actually responded with valid responses. So of course, what's missing is 1,000 minus 636, which is 364. Okay? So again, this column right here is telling us about absolute frequencies, the number of observations for a particular variable or value. Okay. The next column where it says percentage, that is the relative frequency. Okay? Actually, the next two columns where it says percentage and valid percentage, those are relative frequencies. What does that mean? Well, it's relative because we're talking about the absolute number, the absolute frequency divided by whatever we're calling our total. So if we're calling our total 1,000, right? So 156 people responded, premarital sex is always wrong. But what percentage of the entire group of people that we set out to interview, which is 1,000, what percentage of that 1,000 said always wrong? Well, that's 156 divided by that total, 1,000, and we get, as you can see there, 15.6%. Okay? What percent of the people that we wanted to survey, that's 1,000 people, what percent of that said, I don't know, I just don't know? Well, we take 23 and we divide it by that total, so we get 2.3% said that. 2.3% said, listen, I don't know. I have no clue what I think about premarital sex. Okay? But the valid percent, the percent doesn't really tell us a lot, particularly because we have so much missing. 36.4% of our data of that 1,000 people surveyed is missing. And yet we're saying 15% of that, 15.6% of that total number of people we tried to survey, 1,000, said always wrong. But that's not really valid. That's actually not valid. Of the people who responded, right, we can only look at 636. That's the total number of valid responses that we have. So we really should base our percentage off of that. So we call that next column valid percentage. So of the valid percent, 156 people of the 636 people, 24.5% said it's always wrong. Not 15, because it kind of got diluted. If you can see that, it got diluted because of all the missing values that we included and said, hey, let's divide it by 1,000. Really, we shouldn't have divided it by 1,000. We should have probably divided it by 636 because that's the total number of valid responses. So of the people who we actually got surveys responses from, 24.5% said always wrong, it's always wrong. So instead of 5.6% of people saying it's almost always wrong, actually it's 8.8%. Right? So we stop the dilution. We make it a more robust number. We make it a more accurate number by looking at the valid responses. The responses of people who actually responded. Not the missing, not the people who aren't sure what they think, but the actual respondents, okay? And then cumulative percentage is really just telling us, again, you can see here it says cumulative relative frequency because relative means percentage, right? So whether we say cumulative relative frequency or we say cumulative percentage, we know percentage means relative frequency, right? So all we do here is as the word says cumulative, we add things up. That's what cumulative means. You just sum up the stuff that comes next, and then the stuff that comes after that, and then stuff that comes after that. So 24.5%, we just take that across. 24.5% of our valid valid responses said premarital sex is always wrong. But what percent said that and almost always wrong? Well, we add 24.5 plus 8.8, and we get our 33.3. So 33.3% of the valid responses said either always wrong or almost always wrong. What percent said the first three things? Well, we continue to add. We add that 22.6 and we get 56.0%. So what percent of the respondents said, you know what, it's not wrong at all? That's about 44%, right? And we add that to the end and to the 56, and that's our total. That's the total 100%. All right, so let's practice. How many observations are in this frequency table? Okay, since this is the same one we've looked at before, I won't give you too much time because we can see at the very bottom that the number 1,000 is there. So it's 1,000 observations. What variable is being analyzed here? So the variable, you should say, right, is not, we can't say gender, right? We can't say race. We're not measuring that. These values are talking about, they're saying always wrong, almost. What is the question? Well, the question must be that what we see at the top of that table, premarital sex or sex before marriage. What are people's attitudes towards sex before marriage? So that is the question. So therefore, that is our variable. What are the values? Well, we've got 4 valid values. We've got other values here, but they're under the missing category. But so our 4 values, always wrong, almost always wrong, wrong sometimes, not wrong at all. So those are our values. That's it. The other things under missing, we never consider those values, okay? They are there and we need to take account of those, right? But we never say, okay, well, that was a value, because it's not a value. It's missing. It's missing data. Oh, I will say, though, that in this table, whoever the researcher was decided that don't know is missing. But in my studies, and I've seen in other people's studies, don't know is usually sort of neutral. And so it would probably be in between all that 2 and 3 value, where it's, that 3 and 4 value, where it's in between. So we're not saying that it's wrong, not even sometimes, and we're not saying that it's not wrong at all. We're just saying, I don't know. So it has to be somewhere in between Don't know has to be somewhere in between. It is wrong and it's not wrong, right? So it's somewhere in between that. So that's where I personally would have placed it, but the person doing this study decided, no, we need definitive answers, so we're not going to include the don't know value, which is fine for them. What is the absolute frequency of premarital sex is sometimes wrong? I'll give you a second there. Absolute frequency, again, means the number. We're not talking about percentages. We're only talking about the actual number. So premarital sex is sometimes wrong. We look, where do we see that? Sometimes wrong is number 3. So 144 people said it's sometimes wrong. Relative frequency. Now we can start looking at percentages, right? And specifically, let's see, it's asking for the percentage of premarital sex is sometimes wrong compared to, that's important, compared to the total people surveyed. What was the number of people surveyed? You should be saying 1,000, right? Because 1,000 people were surveyed, not how many people had actual valid responses. It's saying compared to the total number of people that we actually tried to survey, right? So that is not our valid responses. That is our regular percentage. So that percentage would be, again, that 3 value. We go over and we see it's 14.4 because it's 144 divided by 1,000. Okay? What percentage of total valid respondents believe that premarital sex is sometimes wrong? So here we go. Again, we're talking about percentages, but which percentage column should we look at? Well, it's telling us outright, actually, that we need to be concerned with total valid responses. So total valid responses is 636. So sometimes wrong, again, that's the 3 value, 144 divided by 636. That should give us 22.6. Okay, so that should be our answer for number 6. What percentage of respondents believe that premarital sex is, I don't like the way I phrased this, at least sometimes wrong. I don't like the way I phrased it. I would say that believe premarital sex is almost always wrong, almost always wrong, almost always wrong, and sometimes wrong. So those three, I would say the cumulative of those 3 would be 56%. So however you can understand that question, please don't allow my words here to kind of confuse you. But yeah, so what is the cumulative starting from sometimes wrong? And that would be 56%. All right, so now that we know how to read these frequency tables, let's look at frequency charts or graphs. Like we did at the very beginning with the divorce rate chart or graph, we use frequency tables, graphs, because a picture is worth 1,000 words. Sometimes the information is so much and so intense that words, or numbers might be too much, and you might just need a picture to just kind of convey what is needed to be conveyed. So graph type selection depends on the number of cases in the data set, the type of variable you're talking about. Remember, interval, ordinal, nominal, even dummy variables, and the type of values of the variables, okay? So here is a line graph, and this line graph, believe it or not, is actually measuring the exact same thing in all 3 graphs. We can see that the x-axis is years, so it's measuring from 1940 to 2000. And we can see the y-axis, it's a little different on each of them, sort of, but it can go anywhere from 0 to 250, and it's measuring death rate, okay, from cancer. So pay attention to what goes where. That's one. We can see what goes on the X and what goes on the Y. And then also, equally and possibly even more important is the scale. Scale absolutely matters because how you stretch the axes and choose your scales can give a different impression. It can completely skew data or make people believe something that is not really the case, right? So we can look at the first graph at the top left and say, cancer rates are not really increasing much. I mean, it's been doing the same thing since 1945, pretty much, right? That's what we might conclude by using the graph that someone scaled the way they did in the top left. Okay? In the top right, we might even say the same thing, but to a lesser degree. Okay, we actually took that graph and stretched it the way it should be so that the 0 to 250 for death rates is a little further out, right? Spread out a little bit more. And then in the bottom graph, we actually shorten that distance, that scale for the y-axis to 120 because we had no reason to even start at 0, right? We had no reason to start at 0 because the lowest death rate in thousands was, what is this, like 130, like 130,000 deaths in 1945. So we had no reason to start at 0, which caused the data to look as if nothing had happened and there is no increasing of cancer death rates. Okay, so scale matters. All right, so frequency charts. We have bar graph here, and each category or each value is represented by a bar. So bar graphs, as you can see here, are good for ordinal or nominal variables, okay? Histograms are used also pretty frequently, and they're used for ordinal or interval level variables, particularly the ones that have relatively small number of different values. The range of values that a variable can take is divided into equal-sized intervals. The histogram shows the frequency that falls in each interval. Okay, so that's why not only can we use interval variables, which have exact numbers, we can use ordinal variables that have ranges, right? So that's important to have recall, like the definition of interval and ordinal and so on, right? So what does this histogram below depict? Say specifically the two arrows. Well, first of all, this histogram is telling us that about percentage of Hispanics by states, so number of states that have whatever percentage of Hispanics we see here. So, for example, where it's clicked, the first arrow to the left is telling us that the height of this bar is 13, right? Then, which means that there are 13 states that have Hispanic percentage of Hispanics between 5% and 9.9%, okay, of Hispanics. And then we have an outlier, a lone star here, and not the Lone Star State of Texas, but New Mexico seems to be an outlier here with 42.1% Hispanics. And it's only one. You can see if you take it all the way across, you can see it's only one. It's not up to 5. It's definitely not 2, but one state, which happens to be New Mexico, has a Hispanic population of about 42%. All right, these are not used so much anymore these days, but I would say, coming from an engineering background, that they're probably still used in the engineering world, especially where you have a lot of numbers that you're dealing with. So stem and leaf plots, best for quickly displaying the distribution of an interval level variable, especially when you want to do it by hand, because it can be easily done by hand. And so that's why I say it's not one that we use so much these days, simply because we have computers and we don't have to do a lot of things by hand these days, you know? And then line graphs, also nice to have. For comparing groups, it's easier to use line graphs. One line represents one category or one group, say white, and the other group is called black, right? We can see here what black and white people's opinions are about premarital sex. And then pie charts. I'm sure you've seen this many times in your many years of living. So we can see what pie charts do here. It's really useful for ordinal or nominal variables, categorical variables, I would say specifically, especially when they don't have so many categories. And sometimes interval level variables if they don't have like infinite number of numbers to have to depict on a pie chart. Just a quick kind of rubric, best use of the charts, just to use whenever you finally get to this section, maybe with your research assignments. All right, that concludes lecture 1. Please feel free to rewind, start over, or go straight to your practice exercise number 1, and get to it, and also homework 1 as well. Thank you for listening. Bye-bye.